200,000 years ago, human-like creatures had evolved with brains and bodies almost like ours. Yet these creatures were not us. Our own species, Homo sapiens, had yet to appear. The study of human evolution is one of the most controversial areas of science. And when archaeologists brought together new fossil proof for the emergence of our own species, it was clear that this would be no ordinary scientific convention.
There had to be tremendous security. The fossils had to be escorted in a convoy from the airport. There also had to be special exhibition cases which were bulletproof and even bomb-proof against attacks by terrorists or creationists.
The meeting was called to discuss one of the most important questions scientists have ever faced: where and when our species first walked the Earth. How did our journey begin? On the southernmost tip of Africa, 200 miles from Cape Town, lies a place called Classis River mouth. When fishermen climbed up into one of the many caves that surround the site, they had no idea what they would uncover. Soon scientists came to investigate what had been found. Part of a skull, the frontal bone above the eyes, important because it lacked the prominent brow ridges that are a distinctive feature of archaic hominids. Then something else, a jawbone with a clearly defined chin, something only humans possess.
The absence of brow ridges and the presence of a chin, these are modern attributes. And this would indicate that we're dealing here with modern people and not with archaic people. This is a human like us, as opposed to archaic kinds of humans who preceded us in Africa.
To those who first examined them, the finds made no sense at all. They seemed to be the wrong bones, in the wrong place, at the wrong time. They were clearly the remains of people just like us, yet they also seemed to be very old, 40,000 years old, if not more. But 40,000 years ago, there weren't meant to be modern humans living in Africa. Scientists were convinced that the only members of our species who existed at that time had evolved many thousands of miles away in what is now France. Ever since modern human remains were found in French caves 150 years ago, it was assumed that our species had evolved in Europe. But British anthropologist Chris Stringer wasn't convinced. He set off on a marathon tour around the fossil archives of Europe, determined to judge the bones for himself. He planned to make the first detailed comparison between two sets of remains, those belonging to early modern humans and those of an older species of hominid, the Neanderthals. We were supposed to have evolved from the Neanderthals, but would the bones bear this out?
Right from the beginning, the Neanderthal fossils that I looked at in Europe seemed to be showing a consistent pattern. They had a double-arched brow ridge at the front. They were long and low. They had almost a spherical shape when viewed from behind. There were also features in the lower jaw and in the rest of the skeleton that seemed to mark them off from the modern human fossils that I was looking at. And if anything, the Neanderthals through time seem to be getting more different from the early modern humans rather than more like them, which was not, of course, what one would expect if they were their ancestors.
Across Europe, in museum after museum, Chris Stringer could find no firm evidence to show how our species might have evolved from the Neanderthals. And by the time he arrived in Paris, at the end of his trip, he was beginning to think that an answer might never be found.
When I got here to Paris, I'd seen and measured a lot of fossils, and I already had a pretty clear idea of their features. But one of the biggest surprises for me here was a fossil from Africa, from Morocco, from a site called Jebel Ihud. And this fossil had been called an African Neanderthal. But as soon as I saw it, I realized that it was not like any Neanderthal I'd seen so far. In particular, the face was flat, the nose was relatively small, the cheekbones were much more like those of a modern human. And so it seemed, at least in the face, to be a better ancestor, potentially, for modern humans than any of the Neanderthals were. And although no one took Africa seriously as a place of origin, the place of origin for modern humans, this fossil, as I analysed and worked on it and similar material, began to suggest that Africa might indeed be the homeland of modern humans.
The idea that our species might have first emerged in Africa was difficult to prove. Finding the true age of the modern human remains found at Classes was the first step. But the technique of radiocarbon dating couldn't look far enough back into the past to be of any use. But then the archaeologists working at the site wondered if there might be a way to date objects found alongside the human remains.
Some of the earliest information we had on dating, fixing the time period when occupation began in this cave came from a humble shell. And this is the operculum, the trapdoor of a turban shell.
Shells contain chemical traces which can reveal how hot or cold the sea was when they first formed. And when tests were carried out on the Classis shells, the results came as quite a surprise.
These came from waters that were as warm as the present. And you get warm waters in the oceans between the ice ages. So this came from the last in-between ice age, in other words, an interglacial period. And that last interglacial period was 120,000 years ago.
Other dating techniques have supported these findings.
And we now have reasonably firmly established that these deposits are in the range between 120 and where they're working 90,000 years old. And it's from the level that they're working where human remains have come. And so we know we can bracket those human remains in a very definite time range.
90,000 years old. The Classis fossils are at least 50,000 years older than any similar human remains found in Europe or elsewhere. Then scientists found new evidence, not in ancient caves, but in our blood. Genetic research began to transform the study of human origins. Taking blood samples from different communities across the world, scientists looked for variations in the genes of people living in Africa, Europe, and Asia. These tiny variants in our genetic makeup take thousands of generations to build up.
We found 199 variants in Africa, we found 98 in Europe, and we found 73 in Asia. So we're seeing a lot more diversity in Africa. And what this suggests is that the Asian and the European populations simply haven't had enough time to accumulate diversity, whereas the African populations have had a lot more time, suggesting that they're an ancestral population. The main conclusion of this work is that all individuals from around the world, whether they be African or of non-African descent, derive from a single common ancestral population that existed in Africa probably around 150,000 years ago.
Everyone alive today, Western or Eastern, black or white, is descended from the same small group of early humans who lived in Africa more than 100,000 years ago. When Chris Stringer presented the theory that our species first evolved in Africa, he got a mixed reception from his scientific peers.
No one doubted that our ancient ancestors had lived there, but certainly the view that Africa could have been the single place of origin of our species was a long way from being demonstrated convincingly.
And while the genetic data supported Chris Stringer's theory that our species was African in origin, now other scientists began to question whether these first African ancestors were fully modern humans.
Many people were prepared to accept that the modern body form had evolved in Africa at quite an early date, but there was still this separate question of when modern human behaviour, when the modern human mind, when language began. And certainly some people then challenged the idea that that had originated over a long period of time in Africa. Some people believe that it was a much more recent development, and therefore the modern anatomy actually evolved before modern human behaviour.
Then, on the same stretch of South Africa's coast, just 100 miles west of Classis, scientists found another cave. The team investigating the site is led by Chris Henshelwood, who has been exploring the caves on this coast for many years.
I first came to this area when I was about 5 years old. As a child, over the years I used to wander around these dunes, and I was always fascinated by what I saw. There were what looked like stone tools to me, lots of shells, perhaps old fireplaces and old bones. Years later I decided to do archaeology, and that's why I'm here today, because I think this area is very rich.
Chris Henshelwood remembered a small cave that had fascinated him as a child. It's little more than a gap in the cliff face, but large enough to offer shelter from the wind and the rain. And when he and his team started to dig down through the cave floor, they soon found evidence of human occupation going back many thousands of years.
The top section of the cave over here dates to within the last 2,000 years, whereas this yellow sand below it was deposited at a very, very much earlier date. Almost certainly this sand blew into the cave about 100,000 years ago. That means that all the layers below this are older than 100,000 years old.
Laid out in the layers of earth was a perfectly preserved record for the occupation of this cave, from the present day to well over 100,000 years ago, the time when our species first emerged. The team at Blombos have removed tons of sand and debris, working down through the cave floor. Concealed in the rubble, they have found a hoard of ancient artifacts. There's a range of stone tools made from a specially hard rock called silkrete, a rock only found 20 miles away, expertly worked to produce razor-sharp, double-sided blades.
That tells me that there was a clear mental template. They knew what they wanted to create. They didn't wander around the landscape, picking up a piece of rock, banging it, and cutting an animal open. This is cognitive thought. This is advanced thought. You know what you want to make. You go to the source, you get the raw material, you bring it back, and you make it, and you make the same thing over and over again to exactly the same precision. I think that is very advanced behavior.
Some of the bone tools found at the site reveal even more about the people who once used them.
This is an awl, a tool that was used for piercing leather. These are very important indeed, because they indicate to us that people 100,000 years ago were probably making clothing.
These tools are of a sophistication and complexity which had only been found in Europe. Here in Africa was new evidence of people with the same kind of skills living 50,000 years earlier. From the same levels as the tools, the Blombos team then made another find, evidence that shellfish had been brought to the cave.
People in early periods generally in the world do not collect shellfish. I think perhaps what it is that they don't realize that shellfish are food. I think you need to have the ability, the brain power, if you want to call it, the cognitive ability to be able to say there's shellfish down there, we can collect them, we can cook them, and we can eat them.
Collecting shellfish marks a dramatic change in behavior. For archaeologists, it is evidence that these people were now thinking about their world in a different way.
So I think what you're seeing here is the kind of behavior where people are able to look at their whole environment and exploit a wide range of foodstuffs.
These species of shellfish are all quite common on the rocks today and are species that were collected and eaten in quantity by the people who lived in the cave. The shellfish are interesting not only because they were a mainstay of diet for coastal people, but also because we think that they were used as bait for catching other marine animals. And we're particularly interested in catching of fish at Blombos Cave because this site is giving us the first good evidence that people 100,000 years ago were capable of catching fish, indeed that they could recognize fish as potential food sources.
Evidence of fishing came early on, with the discovery of large fish bones in the lower layers of the cave.
Fishing is interesting because it's one of those activities that requires cooperation between people in a group. You don't just go down to the rocks and go and fish. You also need to have some kind of template in your mind as to how you're going to go down there, what kind of equipment you're going to need, how you're going to lure the fish in, how you're going to work as a couple of people together to catch that fish.
We think that they were catching them, perhaps by throwing bait into the water, and in a deep gully like this, fairly large fish would very likely take that bait and then be available for people to spear or otherwise try to gaff out of the water.
Fishing like this demonstrates more than just an ability to survive.
It tells us that these people were able to think ahead, to plan ahead, to get an activity together which involved the cooperation of a number of people in that group, and then carry it off. And they carry it off, we know they carry it off because the traces of the fish are in the deposit over here.
Along the coast at Classis, Hilary Deacon has also been looking for evidence of modern human behavior.
Now we're coming up to the top levels of the site, and very nicely exposed here are a series of hearths. Hearths like this occur right the way through the deposit, but they're particularly clear here.
The ash layers of hearths, fires made again and again in the same place, have built up in the cave.
This is the kind of thing that was being done 100,000 years ago. It was done 5,000 years ago, and it's still being done in the present in certain parts of Africa.
For archaeologists, these ash layers show a continuity between the life lived here more recently and the original behavior of the first modern humans 100,000 years ago. But the cliff face also contains other clues to the lives of these early people. Embedded in the rock, Hilary Deacon has found traces of a substance that is loaded with significance.
Red ochre is clays which have been stained by iron oxide, and they have this brilliant red color. In modern-day Africa, in very many places, you have color coding for different parts of life. Red particularly symbolizes living. It symbolizes blood, and this is used in the present as coloring material for people who are going through initiation.
One place where red ochre is still used today in initiation ceremonies and other rituals is Griqua Town, a small community in South Africa's Northern Cape. As the entire community celebrates outside, a group of older women carry out an ancient ceremony designed to mark a young girl's transition to adult life. The girl will be smeared with blood-red paste made from ochre. It's a moving ceremony and an example of symbolic behavior, a characteristic no other species has ever displayed. Chris Henshelwood began looking for red ochre at Blombos, but no trace of it could be found. Then one day, he discovered why.
The people regarded the ochre as being so important that they stored it very carefully. When I excavated these layers, I could put my hand in here and I could take out pieces of ochre that had been stored here for over 100,000 years. I think that shows how important ochre was to these people.
Further examination showed that the ochre had indeed been used.
If you have a look at this piece fairly carefully, You can see there are striations over here. This is where they've taken this piece and they've grated it on a rock. In fact, on this very rock, somebody sat here 100,000 years ago and they rubbed it around to make a fine powder. We have some traces of the powder left here. They're very faint now, but we have tested the powder and it definitely is ochre. We think that people in this cave used it to decorate themselves with and also to decorate bone tools and stone artifacts. In fact, we found evidence of some of the tools and artifacts here with the ochre staining still on it. This bone artifact was used probably as a gouge of some sort. What I think is very unusual about it, most unusual about it, is that it's left the imprint of the maker's hand on the tool on both sides. The maker or the person who was using the artifact had ochre staining on their hands. And here you can very clearly see where this part of the hand has been transferred onto the artifact over here. And if I turn it over, you'll see where my thumb was before. It's left a perfect thumbprint over here in ochre as well.
The people of Blombos clearly valued ochre and used it to decorate their possessions and their bodies. But did they really have the ability to think like us? There was one more piece of evidence in the cave. On the end of a piece of red ochre, there are a series of tiny cut marks.
They've taken a stone point and they've cut lines in one direction and then cut similar lines in the opposite direction, creating a diamond mesh pattern. Deliberately. That's the important point. Deliberately. This is not accidental. And I think they've been trying to create something that's symbolic here. Perhaps we have the earliest evidence of an attempt at creating something you could call art.
The people who lived along the African coast 100,000 years ago were far more sophisticated than earlier members of the human family. They fished, they cooked their food on hearths, they decorated themselves and their artifacts. They thought in a symbolic way. They were fully modern humans. They were us. Then researchers analyzing genetic variations between living human populations made a further discovery about our distant origins.
By comparing the genetic diversity outside of Africa to what we're observing inside of Africa, we've been able to estimate that early in the history of modern humans in Africa, there was subdivision amongst African populations. At some time after that, around 100,000 years ago, there was a migration of a small group, a subset of the African populations, migrated out of Africa, spreading across the rest of the globe.
Soon after our species first evolved, some of our ancestors began to move from Africa and out into the rest of the world. Archaeologists in Australia have recently discovered that modern humans made it to this isolated continent 60,000 years ago, much earlier than anyone had previously thought. scientists began to look for a motive. Why had our ancestors moved so fast and so far from the place where they evolved? What was driving?
In prehistory, we know that most people were hunter-gatherers, foragers. And a hunting and gathering lifestyle is a pretty good lifestyle, but it's not one that you can absolutely count on. However, in caves like Plasses River mouth and Blombos, we find the use of coastal resources, and moving to coastal resources provides a new potential. You have more dependable food, and you have food in larger quantities, and your population can grow. But once it has grown, you're actually harvesting intensively those resources, and the shellfish do respond. They become rare, up to the point that they can disappear completely from beaches. So what you have is that that population that was first allowed to grow now needs to move on in order to support itself. They cannot move back because there's more people behind. So they have to move forward and along the coast. At some time, between 100 and 60,000 years ago, people occupied all this coastline and extended and dispersed down to Southeast Asia and eventually crossed Australia.
To our coast-living ancestors, the world was one long beach, and generation by generation, they moved along it. Coastal migration would have allowed our ancestors to keep moving through a world that they knew.
The interesting thing about the coastal route is that you've got a narrow coastal zone, and if people were adapted to that, then almost they were pre-adapted to go all the way from Africa through southern Asia, all the way towards Australia, more or less staying in one zone, which they were already used to. It does seem astonishing to us that they could have travelled so far, but we have to remember that they weren't exploring for knowledge or gold or glory. They were doing it to survive. And of course, 10 or 20,000 miles seems an enormous distance to us, but they only had to expand their territories by 1 mile every year. And in 10,000 years, they'd gone 10,000 miles.
And on this great journey, scientists believe that our species began to acquire vital new skills.
By the time you have the first modern humans, they all have the potential of invention that we have. And I think that's actually what makes them modern. They can invent solutions to new problems. So once exposed to these coastal areas, and once they actually manage to control these resources, from there to a boat, from there to a bigger boat, from there to nets, from there to harpoons, it's only a step.
But not all modern humans took the coastal route out of Africa. To the north of the continent, there are traces of their presence further inland. A field of stones, where modern humans came to find the raw material for tools.
this place was used as a quarry. People came here to make stone tools, and the hillside's littered with stone tools. I've just found one. And a few years ago, some Belgian archaeologists very unexpectedly found a human skeleton in this pit.
The skeleton found among these rocks was dated to 60,000 years old.
So there were modern human people here making these stone tools, quarrying them, then taking them away at least 60,000 years ago.
The significance of this quarry field is its proximity to another natural route out of Africa, the River Nile. This river valley marks the course for what scientists believe was a second and later wave of migration.
The Nile Valley was like a permanent oasis running for thousands of miles. Humans would have been here in the Stone Age, living on the banks of the river, and following the river in a northerly direction would have led them right up into northeast Africa and into the Middle East.
In time, these migrants also moved on, around the Mediterranean Sea, further north into Europe, gradually populating the world with members of our own species. We do not yet know how many of us there were at the very beginning. It is difficult to calculate the size of the first populations. But however many of us, or however few there were, places like Blombos and Classis are where the very first of our kind emerged. And these beaches were perhaps our first home.
Our species has come a long way in a short time, and what unites us in terms of our biology and our shared history is very important. We shouldn't forget that. And despite the differences we have around the world now, those have grown up very recently, and I think what we share in common should be as important or more important than the things which divide us.
There were other species of human on the Earth as we first emerged from Africa. What happened when we met would put our unique ingenuity to its greatest test. In the next program, we enter the final chapter of our story, the meeting between us and the other species who had lived undisturbed until we arrived.